Hello, good afternoon students. Welcome to the session. Welcome to one more fabulous session from Infinity Lane by Sri Chaitanya. I am Suresh, Faculty of Chemistry. How are you all, my dear students? Hi, Dhruv. Good afternoon. Hello. Yes, can you able to see me? Can you able to hear me? Just give a confirmation. एक फायर इमोजी डालो, थम्स अप डालो, फटाफट जल्दी से. हम करेंगे आज केमिकल बॉन्डिंग का वैलेंस बॉन्ड थ्योरी शुरू करना अभी. हाय Vanga Annamani, fine, good. Great to see, and this is NEET STEP UP program 2025 on YouTube platform by Infinity Lane by Sri Chaitanya. How are you all? And this is about chemical bonding today's class. And in this NEET STEP UP 2025 program, we are providing you physics, chemistry and biology lessons right from 12 o'clock to evening 6 o'clock. And these sessions are absolutely free, and we are going to give you outstanding content as far as NEET examination is concerned. So we request you to just like and share and subscribe this NEET channel, and also in the description box you have been given Telegram link and you join there, so that you will be getting सारे के सारे session का notes PDF फॉर्म में आपको मिल जाएगा, है ना. सो अभी तक फिलहाल हम केमिकल बॉन्डिंग में आयोनिक बॉन्ड फाजान्स रूल खत्म कर चुका. अभी हम करेंगे कोवेलेंट बॉन्ड एंड we'll go with formal charge and resonance, and we'll eventually get into VSEPR theory, and after that we are going to get into valence bond theory till hybridization. That is the content of today's topic, है ना. Yes, very good. Now let's talk about Fajans rule. एक बार थोड़ा सा आपका रिवाइज करना, बिकॉज Fajans rule का हिसाब से आपका कुछ क्वेश्चंस आने की ज्यादा संभावना है. ये Fajans rule किसके लिए इस्तेमाल कर सकते हैं? आप Fajans rule इस्तेमाल कर सकते हैं ये relative covalent nature or relative ionic nature of the compounds. So it says that covalent nature is directly proportional to polarization. So what is the polarization? Polarization is deformation of anion by cation is called polarization. Hello Dhruv, can you able to hear me? Just give a confirmation. Anamani, just give a confirmation. Can you able to hear me? Hello. Yeah. So let's go ahead. Increases the size of cation, increases the ionic nature. Yes, that's good. And also size. As the size of anion increases, polarizability increases, it's clear. And you can see as charge on either cation or anion increases, polarization increases. So as far as that order of increasing covalent character, NaCl, MgCl2, AlCl3, SaCl4, here chlorine is constant and cation is variable, so that Na plus 1, magnesium plus 2, aluminum plus 3 and silicon plus 4. So as positive charge increases, covalent character increases. That's what I want to say. Now you can see lattice energy ये अच्छा बात है. So lattice energy, based on lattice energy, you will be getting a very good number of questions, not only in this chemical bonding but also in thermodynamics as well. You will get a question, right? So we'll see what is the lattice energy. What is the lattice? Ionic crystal is called lattice, है ना. So it is the lattice energy of ionic crystal is the amount of energy released when 1 mole of ionic solid is formed from its gaseous ions. That is what you call it as a lattice energy. So let's say here the magnitude of the lattice energy, it is indicated by U. So it is an exothermic process. So minus U is equal to K, Z plus Z minus, what is this? Z, magnitude of the positive charge and the magnitude of the negative charge upon the distance. Okay. So as the charge on the cation or the charge on the anion increases, lattice energy increases. More the lattice energy, more will be the stabilization of the ionic crystal, ionic solid. So based on that, you can say how the melting point and the solubility is decided. So here I want to say about the compounds of ions with higher charges have large lattice energies than the compounds with lower charges. So lattice energy is in the order sodium plus 1, magnesium plus 2, aluminum plus 3. F minus 1, minus 2, minus 3. So as the charge quantity increases, its lattice energy increases. As lattice energy increases, its stability increases. So properties of ionic compounds. Properties of ionic compounds is very important here. Hardness and brittleness. Ionic compounds are hard and brittle compounds, and they have high melting point and boiling points because the cation and anion are held by strong intermolecular forces. Therefore, the ionic substances do have strong intermolecular forces, and they have high melting point and boiling point. They are hard and brittle crystalline solids. And the solubility. Ionic compounds are soluble in water. Ionic compounds are soluble in water and any polar solvents. And the solubility is directly proportional to dielectric constant of the solvent that is used. And the solubility का जो formula है, if lattice energy is less than hydration energy, then the compound is said to be soluble in water. Whereas lattice energy is greater than hydration energy is nothing but insoluble in water. So this is the link between the hydration energy and the lattice energy, right? Very good. Now electrical conductivity. So ionic compounds in the solid state, they are poor conductor. In the molten state, they are good conductors, and in this aqueous state, they are excellent conductors. That is important. Hi, crazy boy. What, you want to go crazy? Right. Now, ionic reactions, the chemical reactions that are involved by the ionic compounds are very fast. So, example you can say here, sodium chloride is reacted with silver nitrate. You are going to get silver chloride, a white precipitate. Yes. Okay, so the reaction, the formation of silver precipitate you can visualize, and the time that is taken for this reaction is around 10 to the power of minus 9 to 10 to the power minus 12 seconds. So that much fast these reactions are, right? That's good. And space isomerism. Ionic compounds are directionless. So ionic compounds are directionless. They have no direction. They don't want to store stereoisomerism. This type of questions will come in statement 1 and statement 2 type questions in NEET examination, my dear students. So theory oriented questions you are going to get from this kind of topics. So statement 1 you can say the ionic compounds do not show space isomerism or stereoisomerism. In other ways, the statement 2 says ionic bond is non-directional. So we can claim this as statement 1 and statement 2 is correct, and statement 2 is the correct explanation of statement 1. Hope you understand. So that kind of, in the NEET examination preparation, the concepts we are going to discuss, as far as the concepts are concerned, we are discussing the questions as well, right? That's good, my dear students. Here we will go into the covalent bond. So what is a covalent bond? Covalent bond is a mutual sharing of electron between two atoms. Covalent bond, in this covalent bond you have polar and non-polar. So non-polar means you have two similar atoms of the atoms of same element. So in the polar you can say only atoms of different elements you can take. So it is between two same non-metal atoms. Okay, equal sharing of electrons takes place. Okay, such are called non-polar covalent bond. Examples: H2, Cl2, F2, Br2, I2 kind of things will come, right? But and in between different non-metals with unequal sharing of electrons like HCl and ICl, it gives you polar covalent bond. So homoatomic covalent bond is non-polar, homoatomic covalent bond is polar, non-polar, and heteroatomic covalent bond is polar. Henna, that's good, very nice. So let's go ahead. Yes, so in this Lewis dot models, so hydrogen, it has one electron and one electron is being shared. Hydrogen fluoride and the chlorine, you can say till octet, either octet or duplet to get the stability. Among octet and duplet, which is more stable? Crazy boy, who is that? So today Richa is not seen, Ishita is not seen, went to school it seems. Okay, so here 8 electrons in outer shell is called octet and 2 electrons in the outer shell is called duplet. So duplet is more stable as compared to octet. And this is what octet rule. In the previous class we discussed about this octet rule. In this octet rule, you just seen 8 electrons and less than 8 electrons and more than 8 electrons. So incomplete octet. Some compounds, the number of electrons surrounding the central atom is a stable molecule is fewer than the 8. So less than 8 electrons is called incomplete octet or hypovalent, you can say. In this hypovalent, any beryllium boron compounds you can take it as an example, AlCl3 as well. And expanded octet greater than 8 electrons, so it is also called a super octet. In the super octet, more than 8 electrons are there, you can take PCl5 and SF6 as an example. PCl5, SF6 and IF7 is an example. Okay, now you can say odd electron molecules. This is very important, very important. Which of the molecular species is odd electrons? Some molecule contain odd number of electrons. You can see nitric oxide, nitrogen dioxide, chlorine dioxide comes under the category. So you can check the outermost electrons with nitrogen and oxygen. You can say nitric oxide. It contains outer shell 5 electrons, oxygen 6 electrons. 5 plus 6 is equal to 11. It is an odd electron species. If it is even electron, odd electron, you can check it. That is only the trick, my dear students. Now, formal charge is very important. Formal charge is very important. It is there in the CBSE textbook. Those students who are preparing for CBSE as well as 11th standard and 11th to 12th promoted and 12th dropped NEET examination preparing students. So these lectures are super useful to you guys and you all just follow these lectures. For following क्या क्या क्लास कब होगा ये टेलीग्राम चैनल में आपको पूरा इंफॉर्मेशन मिल जाएगा and you just hit the bell button and subscribe it so that you will be getting the notification for our sessions, my dear students. है ना? Let's talk about the formal charge. Formal charge is the charge that we can calculate in a molecule for an atom. So by using a formula, this is your formula, you can see. So this formal charge is useful to check अगर जो लुईस स्ट्रक्चर अब बनाए है ना, ये लुईस स्ट्रक्चर ठीक है नहीं है. जो लुईस स्ट्रक्चर है ना, ये इमेजिनरी स्ट्रक्चर है. ओके, सो इमेजिनरी स्ट्रक्चर असली क्या ठीक है नहीं है, गलत स्ट्रक्चर है. ये चेक करने के लिए फॉर्मल चार्ज इस्तेमाल करना पड़ता है बेटा. सो फॉर्मल चार्ज कैन बी कैलकुलेटेड बाय यूजिंग number of valence electron on neutral atom minus 2 into lone pair of electron on that atom minus number of bond pair of electrons, right? So you can say, or let us consider the ozone molecule. ozono molecule, the Lewis structure is given imaginary oxygen, oxygen, oxygen. There are 3 oxygen atoms, oxygen atom number 1, oxygen atom number 2, oxygen atom number 3. Henan? Right. In that, the center oxygen atom marked as number 1, that is equal to ऑक्सीजन इलेक्ट्रॉनिक कॉन्फ़िगरेशन का हिसाब से वैलेंस इलेक्ट्रॉन्स 2 है, 6 है, -2 -1/2 into 6, that is equal to, it is +1 मिलेगा. And the end oxygen atom marked as a 2, इसके लिए, so 6 - 4, because it has only 2 bonds, and half into 4 is equal to 0, that is going to be 0 here. And the end oxygen atom marked 3, my dear students, here. So 6 - 6 minus half into 2, because it has only 1 bond contain 2 electrons, that is equal to -1. So that sum of the formal charges of every atom in this molecule supposed to be equal to the charge on the molecule. So it is going to be 0 + 1 - 1 is equal to 0. That is the overall charge. So you can say this structure is going to be correct, and it can be given as oxygen, oxygen +1, oxygen -1. That is what you call it as formal charge, right? And you can check this nitric oxide, nitrogen dioxide, nitrous oxide structures भी एक बार. Okay, you are going to get the same N2O. You can get this structure or you can get this structure, right? So you can take anything. Nitrogen first atom, nitrogen second atom, apply formula. Nitrogen first atom is going to be -1, and nitrogen second atom is going to be +1, and oxygen is going to get 0. Like that you can calculate the formal charge of nitrous oxide. What is nitrous oxide here? That is laughing gas. N2O is otherwise called laughing gas. Now a question. So whenever question comes now, students started charting and they are giving the various answers. I would like to see the answers, my dear students. Yeah, which of the following has odd electron species? Jaldi batao. Any answer? Any answer is admitted. Let it be correct answer, let it be wrong answer. Okay, so here chlorine oxide ClO3 is odd electron species. So Cl double bond O, double bond O, double bond O, like this. It is a chlorine oxide. Done. And which of the following obeys octet rule? Which of the following obeys octet rule? Yes, it is said too. Wow, wonderful answer. So if you talk about the beryllium, it has only 2 electrons, and the chlorine so beryllium has only 2 + 2, 4 electrons. So your answer is not correct. My answer is going to be SF4. It is going to be SF4 is not. SF4 is not. It is about NCl3. It is about NCl3. Nitrogen, chlorine, chlorine, chlorine. So if you can check here, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, octet. Clear? Fine, that's good. Now, coordinate covalent bond. So, coordinate covalent bond is a special type of covalent bond. Actually, in the covalent bond, 2 atoms mutually share, contribute the electron to form a bond. Whereas, here, what do you say, coordinate covalent bond is otherwise called dative bond. In this dative bond, you can say it is a type of covalent bond, but only one atom donates and another atom do not contribute, and both atoms are going to be shared. That is what you call it as a coordinate covalent bond. So it is a special type of covalent bond where one atom contribute 2 electrons, another atom also share the electrons. That is what you call it as a coordinate covalent bond. An atom act as a donor must have at least one lone pair of electrons in the valence shell. So it acts as a Lewis base, and ammonia and water, okay, and SnCl2, okay. So you can also say an atom act as an acceptor must have an empty orbital to accommodate the accept lone pair of electron. It acts as a Lewis acids. So in this you can say H plus, Bf3, LCl3, BCl3. You can take an example. So I want to talk about ammonia boron trifluoride. Ammonia, lone pair of electron is there, Bf3, you have vacant orbital, so this electron is transferred, so that you can say ammonia boron trifluoride compound like this, NH3, hydrogen, hydrogen and hydrogen, boron, fluorine, fluorine and fluorine, and this is what you call it as dative bond. The dative bond is given in the arrow mark in a direction from donor to acceptor. Clear? That's good. And talking about some other examples here, carbon monoxide, HNO3, so tetraamine copper 2 and AgCN twice and I3 minus also. Talking about ozone, sulfur dioxide according to octet rule and SO3 according to octet rule. These are the structures. Any doubt? Yes. If you have any doubt, put in the chat box. Otherwise, a thumbs up or emoji, fire emoji dalna. Ha, come on. Any doubt? Yes. Now, VSEPR theory. It's one of the best theories that I like from the chemical bonding, dear students, because the chemical reactivity and the property of a compound based on its structure and its shape. I'll tell you the importance of the shape of the molecule. Ice is a solid H2O. So it's, hey, Uday Niwal, you came late. What happened? Hello, you came late. What happened, my dear students? Without you, this class is getting bored for me. So many students are there. They are engaging me. Don't worry. Okay, how are you, my dear beta? Okay. So, ice is a solid. So, solid floating on a liquid. How it is possible? Solid ice floats on water. So, you will be punctual. No problem. Solid is floating on water means the density of ice is less than the water. Why? I can say it has open cage structure due to hydrogen bonding because of the structure of the water is bent. It is tetrahedrally, it's showing hydrogen bonding. So the shape, the shape of the water molecule is very, very important. It plays a crucial role there. So we can say the shape of any molecule makes its specific characteristics. In that, to say a shape of the molecule, we use valence shell electron pair repulsion theory, that is VSEPR theory. In this, I can say, I would like to say here, the shape of the molecule, it all depends on the number of electron pairs in a molecule, central atom, and central atom bonded to bonded atoms. The central atom has electron pairs on its valence shell. So it depends on the number of electron pairs, its shape is decided. It is based on number of electron pairs 2, 3, 4, 5, 6, 7. If only 2 pairs are there, it is showing that linear आपका जैसा है. So linear means let us say A is a central atom, B is a bonded atom, B is the bonded atom. Linear आपको ऐसे देखेगा, आपका angle 180 होगा. You understand, that is about linear, right? And talking about a planar triangular, in this planar triangular you can say A, B and B and B. So it is what you call it as a planar triangular. It is 120 and it is tetrahedral. I'll use the other side. It is tetrahedral. It appears like this, that is tetrahedral. Trigonal, bipyramidal. So this is trigonal and on the triangle एक pyramid ऊपर से नीचे से और एक pyramid दिखेगा आपको. So you want to check it like this, you can check it like this. So this is your triangular bipyramidal structure. So this is your triangle and ऊपर से एक pyramid दिखेगा आपको. हाँ, एक pyramid है, नीचे से और एक pyramid है. So this is what you call a triangular bipyramidal. आपका देखने का आदत होना चाहिए बेटा. So this is your triangular bipyramidal, right? Yes. And octahedron and pentagonal bipyramidal structures comes like that. Yes, very good. Let's talk about the main course. The shape of the molecule is decided by the repulsions among the electron pairs. किसका electron pairs के? जो central atom होता है ना, जो सब मॉलिक्यूल में, ये सेंट्रल एटम का ऊपर वैलेंस इलेक्ट्रॉन्स में ये जोड़ी से जोड़ी होने, दैट इज व्हाट यू कॉल इट इज इलेक्ट्रॉन पेयर्स. ये पेयर्स दो तरीका होता है, बॉन्ड पेयर्स एंड लोन पेयर्स. सो लोन पेयर ऑफ इलेक्ट्रॉन एलपी इज द पेयर ऑफ इलेक्ट्रॉन डू नॉट पार्टिसिपेट, वेयर इज द बॉन्ड पेयर ऑफ द इलेक्ट्रॉन दैट पार्टिसिपेट इन द बॉन्डिंग. So the electron pairs makes the repulsions among themselves, my dear students. Uday. So when these repulsions होता है ना, repulsions का वजह से इसका अभिनव क्यों आज कॉलेज नहीं किया, क्यों? Why? Okay. अभिनव आज ना क्यों गया? ओके. सो ये इलेक्ट्रॉन रिपल्शंस का वजह से ये स्ट्रक्चर डिसाइड कर जाएगा. सो लोन पेयर रिपल्शन ऑन लोन पेयर is greater than bond pair repulsion on lone pair is greater than bond pair repulsion, my dear students. So मिल गया ना? वेरी गुड, थैंक यू. आपसे मिलने के लिए वेरी गुड. नाइस. So the presence of lone pair on the central atom causes slight distortion of the bond and forms a non-ideal shape. हाँ, शेप और एंगल याद करना है उदय निवाल. Yes. Now the magnitude of the repulsion between the bond pairs of electron depends upon the electronegativity difference between the atoms. Okay, पहले हम देखेंगे lone pair नहीं है, regular shape आना है. If lone pair is present, irregular shapes आना है. So जो टेबल आपको दिया पहले ये रेगुलर शेप का है, शेप ऑफ द मॉलिक्यूलर आयन. सो उसमें कुछ लोन पेयर नहीं है, बट अगर लोन पेयर होगा तो क्या होगा? सो विल सी ए टैबुलर फॉर्म बेस्ड ऑन दिस टैबुलर फॉर्म. सो मॉलिक्यूल विथ नो लोन पेयर्स ऑफ सेंट्रल एटम. सो Ab2 beryllium chloride. So that we discuss beryllium and chlorine and chlorine. So this is your bond pair of electron and this is your bond pair of electron. These electron pairs are arranged around space in such a way that the among them repulsion supposed to be minimum, so that it gives a particular geometry that is called a linear geometry or a linear shape. Okay, so Ab3 boron trifluoride I want to give you. So boron, it has 3 electrons and fluorine 1 electron, so that boron has 3 bond pair of electrons. So it gives, what is the shape of the molecule? Trigonal planar, planar triangular. So it is a linear shape. It is trigonal planar. Trigonal planar, right? Now let's talk about Ab4 molecule, methane. In this methane, carbon gives 1 electron and hydrogen gives 1 electron, so that 4 pairs of electrons. So it gives a tetrahedral shape. How do you get a tetrahedral shape? You can get a tetrahedral shape like this. And the angle here 109 degrees 28 minutes, this 109 degrees 28 minutes, you can say tetrahedral angle. It's a famous tetrahedral angle, and the shape is going to be tetrahedral. Tetrahedral. And Ab5 phosphorus pentachloride, phosphorus pentachloride. So in this phosphorus pentachloride you have phosphorus is central atom, chlorine, 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 so 5 bond pairs of electrons. In this you can see a trigonal bipyramidal shape. In this you can have this 90 angle here and 120 angle here, and this bond is axial bond, and this bond is axial bond, this bond is equatorial bond, equatorial bond, equatorial bond. Okay, so there are 3 equatorial bonds and 2 axial bonds. Equatorial bonds short and axial bonds long, and equatorial bonds short का वजह से ये strong होगा and axial bonds long का वजह से ये weak होगा. Yes, very good. And Ab6 sulfur hexafluoride, it is octahedral. Octahedral. यहाँ पर हर बॉन्ड एंगल 90 होगा, 90 होगा. सल्फर हेक्साफ्लोराइड ये सिमेट्रिकल ऑक्टाहेड्रल शेप का वजह से SF6 हमेशा ज्यादा स्टेबल होगा, very very stable. Okay, this is used in electronic capacitors and all. And you can see molecules with lone pair of electrons on the central atom. फिलहाल हम देख चुका molecule with no lone pair of electron. अगर lone pair of electron आएंगे तो so structure क्या होगा? So you can say A is the central atom, B is the bonded atom, E stands here, it is lone pair of electrons. Agar E means E1, one lone pair is there, E, one lone pair is there, E2, two lone pairs, E, one lone pair, E2, E3, three lone pairs. So you can see A, B to E. Central atom A, दो bond pair है, one lone pair है. So that it is going to be A, B to E. You can say structure A, B, lone pair of electron, that is A, B to A. Shape is V shape. Here you don't have to memorize the angle. Okay, that's very good. Yeah, you know, it's my pleasure for you guys. I just want to do anything for you. उदय, हाँ इलेक्ट्रॉन पेयर को एक बार शो करना. हाँ मैं दिखा देता हूँ बेटा, एक मिनट. Okay, so let's do this question. After that we can use the entire space. ठीक है? Maximum number of planar atoms in SF6 molecule. SF6 का स्ट्रक्चर देख चुका. Maximum number of planar atoms. You can see NEET एग्जामिनेशन में ऐसे क्वेश्चंस पूछेगा. कौन देगा आंसर? बहुत ही इंपॉर्टेंट है, बहुत ही इंपॉर्टेंट का है. SF6 का स्ट्रक्चर देखो, SF6 का स्ट्रक्चर सल्फर, फ्लोरीन, 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 फ्लोरीन एंड ए फ्लोरीन एंड फ्लोरीन। मैक्सिमम एक ही प्लेन में आपका कितना एटम्स, ये मान लो ये एक प्लेन है, ये प्लेन में एक एटम है, ये वाला एक एटम है। सो हमका देखता है 5 एटम्स मैक्सिमम कैन बी सीन ऑन वन प्लेन, है ना। सो आई जस्ट वांट टू से इट इज गोइंग टू बी वन। नीट एग्जामिनेशन में ऐसे क्वेश्चंस देखना है। उदय निवाल, इट इज 5, इट इज 5। स्ट्रक्चर देखते हैं कैसे, ये चीज बहुत ही इंपॉर्टेंट का है, ठीक है बेटा। नाउ जस्ट वांट टू गो इन द प्रीवियस वन, इट इज SnCl2। हम SnCl2 का स्ट्रक्चर कैसे देखना, उदय निवाल, इसका उदय निवाल का एक डाउट है। आई जस्ट वांट टू टेक SnCl2 एज एन एग्जांपल, है ना। Sn, इसका नंबर ऑफ वैलेंस इलेक्ट्रॉन आपको कैसे पता चलेगा, बोला। कार्बन, सिलिकॉन, जर्मेनियम, टिन, लेड, सबको वैलेंस इलेक्ट्रॉन कॉन्फ़िगरेशन NS2 NP4 ना, NP2 ना, NS2 NP2। So 4 electrons are there in the valence shell, right beta? Yes. So Sn 1 2 3 4, chlorine, chlorine, okay. Now we can say Sn having lone pairs 1, bond pairs 2, so it is AB2E। ये टेबुलर फॉर्मूला AB2E का हिसाब से आपका शेप V शेप होगा। गॉट इट। हर स्ट्रक्चर का आप ऐसे देखना, AB2E, AB3E, इट इज गोइंग टू बी अमोनिया पिरामिडल। 107 का है अमोनिया पिरामिडल, कैसे देखते हैं आपका, अमोनिया, नाइट्रोजन में कितने इलेक्ट्रॉन्स है ऊपर, सो इट हैज N1s2 2s2 2p 3 5 इलेक्ट्रॉन्स, है ना। सो हाइड्रोजन एक इलेक्ट्रॉन है, हाइड्रोजन एक इलेक्ट्रॉन है, हाइड्रोजन एक इलेक्ट्रॉन है। सो दैट you can see a bond between here, bond between here, bond between here, so that bond pairs आपका 3 है, lone pairs आपका 1 है, so it is AB3E। got it? It is AB3E। it is shape is going to be pyramidal, pyramidal, it is pyramidal। So you have a geometry and a shape. So I just want to use steric number. So steric number is equal to number of bond pairs plus number of lone pairs. Yeah. And steric number decides geometry, steric number decides geometry of electron pairs around the central atom, whereas bond pairs decides the shape of the molecule. Here the shape of the molecule is pyramidal, but the steric number is 1, 2, 3, bond pairs, 1 lone pair, total 4. Steric number 4 means it is tetrahedral, that's it. Right? Yeah, we have to follow that. And one more. So, octahedral molecule among the following, who can give this? Jaldi, Uday, Abhinav, who will give this? Ha, yes. Who want to give? कम से कम आंसर देना यार उदय. SF6 इन द पिछले चीज में A वाला SF6 था ना. In this SF6 you can see octahedral, 4 faces on above and 4 faces on below. So it is octahedral geometry. So here it is shown octahedral molecule among the following is, you can say SF6, SF6, है ना? It's very simple. The shape of water molecule and bond angle in water molecule according to hybridization concept respectively are. So we know it is sp3 hybridization. So it is angular and it is 104.3. So it is tetrahedral and according to hybridization. Okay, the shape of water molecule actual, it is bent and 104.3. According to geometry is given by hybridization. It is going to be 109 degrees 28 minutes and it is tetrahedral. It is tetrahedral. Okay? Yes. And the shape of AB3E molecule is, try from the tabular form, you can try. Can you try? Yes, the shape of AB3E. A, E stands for B, B, B. It is pyramidal. Ammonia का जैसे. It is pyramidal, है ना? That's fine. Which of the following molecules sigma bonds are formed by the overlap sp3? So we will discuss after VBT. Which of the following is pyramidal in structure? Which of the following is pyramidal in structure? Come on, make it fast. What is this count? Which of the following has a square pyramidal in structure? Square pyramidal. IF7 is not square pyramidal, are they? BR, F, 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 F. It is BRF5, square pyramidal in shape. Square pyramidal in shape. है ना? Very good, nice. Very good, nice. So the content what we have is a quite useful content, and the lone pairs present in ClF3 and SFs are present respectively are. It's a quite logical question. Quite logical question. Who will do this? Abhinav, where are you? Abhinav? Okay, Uday Niwal, iska answer ClF3 and SCl4. This kind of questions are quite important for NEET examination. You can see it is all about इक्वेटोरियल एंड इक्वेटोरियल. सो ये सिंपल ट्रिक आपको देना चाहता हूं, जहां पर लोन पेयर ऑफ इलेक्ट्रॉन्स और मल्टीपल बॉन्ड्स आ रहा है ना, वो एक्सियल पोजीशंस में आने का संभावना है किसका, ये रिपल्शंस कम से कम होगा. सो लेट अस टॉक अबाउट Cl F3. so that F and F, and it has a lone pair of electrons, and the lone pair of electrons are there in the axial position of the triangular. The electron geometry is going to be trigonal bipyramidal, and the lone pairs are going to be at equatorial positions. I just want to say it is about equatorial only, equatorial positions only. Even SCl4 also, let us talk about SCl4. Yes, now we can say here it is like this. Okay, this is equatorial position again, Uday. Got it? Very nice. You just look into this. I'll come up with a question. Uday, I already mentioned, anyways, as you asked, I just want to talk about this. In trigonal bipyramidal structure, the bond which is going towards the equator of the triangle, that is called equatorial bonds, and the bond which is above and below the triangle are called axial bonds. Got it? In the trigonal bipyramidal, you have two types of bonds, axial bonds and equatorial bonds. Got it? Clear? Now let's go ahead with one more, resonance. What is the meaning of resonance? Resonance is a phenomena that we already discussed in the general organic chemistry. So for the name's sake, I just want to discuss here about the resonance. So resonance is an hypothetical phenomena. More than one structure is drawn to explain all the properties, but none of this structure actually explains the actual structure of the molecule, but the hybrid of all the drawn structures explains the structure, and it explains the molecule properties as well. So those contributed structures are called resonating structures or canonical structures, and the hybrid of this structure is known as resonance hybrid, and the phenomena is known as resonance. So actually ozone exists not like this. This is a one hypothetical structure and this is another hypothetical structure. So when it comes to the reality, ozone exists like this. So these are called resonating structures, and canonical structures or contributing structures, and this is what you call it, hybrid of these two. So that is called resonance hybrid. Okay. Oh wow. Now so you can say in this hypothetical structure, single bond 148 picometers and double bond 121 picometers, but hybrid contain both the properties which has 128 picometer. That I want to explain. So you download these notes from your channel, so that you have to just subscribe or join in that Telegram channel. You will get every point as a PDF format, right? So सबका free of cost है बेटा. So you please join in this NEET STEP UP program, so that you are going to get every update of it. Okay, let's talk about this. So carbonate structure भी ऐसे होगा, right? So उदय निवाल, hope you understand. अभिनव कहाँ गए तू? हाँ अभिनव, that's good, nice. Now let's see resonance energy. So I just want to say this structure has some energy. You already joined. This structure has some energy, canonical structure, and the resonance hybrid has some energy, right? So you can say in this is a resonance energy and this is the resonating structure and this is resonance hybrid. So the energy difference between these two is what you call it as a resonance energy. So definitely my students every year near about 100, more than 100 students going to the medical colleges, Uday, okay? Yes, my students, IITs also, many of the students are around all IITs, NITs and medical colleges, my students are there, okay? And my students make the group of friendship there, okay? Because we are popular in teaching medical entrances and engineering entrances, na? So that's the reason why students, why you are Suresh Sir ka student and I say, I say, okay? That's good. Okay, now the energy gap between one of the resonating structure and the resonance hybrid is called resonance energy. That's good, thank you. So that's what I want to say here. Resonance energy, higher the, suppose E1, E2 and E3 are the energies of the three structures for a molecule. E3 is the lowest energy, most stable canonical form. If E0 is the experimentally determined value, then the difference between and this is known as a resonance energy. You can also say like that. Yes, thank you very much, Uday. Okay, more the resonating, this is what diagrammatically explaining this. Okay, this is experimentally determined value and this is one of the proposed structure and the gap जो है ना, ये gap is called resonance energy. अगर ज़्यादा resonance energy है, stability भी ज़्यादा होगा. Is directly proportional to resonance energy. Okay. So how many resonating structures are possible for NO3 minus ion? जल्दी बोलो. हाँ पक्का उदय, पक्का ये YouTube कंटेंट में ये मेडिकल कॉलेज में घुसने का काफ़ी है. Do I need to enroll in a paid batch? No. आपका मर्जी. अगर इन्फिनिटी लेन में आपका आना चाहता हो तो कोई एक बैच पकड़ के आ सकते, और अदरवाइज ये यूट्यूब चैनल काफ़ी है. ठीक है, वेरी गुड. Because we are giving the content in such a way that no point is missing out of NEET, and we are also giving a very good tricks, we are doing a very good questions, and we are giving a very good notes in the PPT format and PDF conversion करके आपको दे रहा हूँ ना. So what not everything, and eminent faculties is coming in front of you and teaching. और इससे ज़्यादा क्या चाहिए? Option B, हाँ, yes, you want to say option B, it is a nitrate ion, NO3 minus, okay, N है ना, और क्या चीज़ है? ठीक है, ये तीन स्ट्रक्चर्स. Yes, it is. And according to the concept of resonance among the ions OCl minus OCl 2 minus 3 minus 4, but the most stable ion is. Can I give you the trick? Can I give you the trick? More the number of resonating structures, more is the stability. Yes, that is your trick, my dear students. yes it is. इसका more the number of terminal atoms जो है ना, more the number of stability होगा. That's good. उदय आप ट्रिक पकड़ के जल्दी कर रहे हैं. Nice grasping power, appreciated. Right. So in the resonance structure CO3 minus 2 is not observed. Okay. Okay, we can leave it. Yeah, talking about valence bond theory. Valence bond theory. So it is proposed by Hitler and London. According to this, a stable bond between two atoms are formed when the attraction forces are equal to the repulsion forces. And also it is given as the orbital concept, orbital overlapping. So a covalent bond is formed by the overlapping of atomic orbitals, and these atomic orbitals, a covalent bond is formed by the overlapping of atomic orbitals of valence shell of two atoms. And जो overlapping है ना, ये दो तरीका है. The atomic orbital only in the valence shell will with unpaired electron is going to take part in this overlapping with opposite spin. And the atomic orbital of valence shell with the paired electron do not participate in the process of overlapping, hence do not contribute towards the bond formation. It forms lone pairs. है ना? And overlapping, it is of two types of overlapping and nature of overlapping of the bonds. Depending upon the type of overlapping, the covalent bond is of two types, sigma bond and pi bond. Sigma bond, ये sigma bond axial overlapping का है, and this overlapping is directional. And head-on overlapping, sigma bond is formed by any one of the following type of combinations of ion. S orbital का बीच में overlapping होगा. ये s orbital का है और एक s orbital के बीच में overlapping चल रहे हैं. Example हाइड्रोजन का, right? And sp overlapping का है. ये s orbital and p orbital है ना, sp overlapping कर रहे हैं ना. हाँ, orbital means the probability of finding of electron where it is maximum is called orbital, my dear students. Here orbital is of orbital, my dear students, this is s orbital, it is spherical. एटॉमिक स्ट्रक्चर का एक बार देखना अभी. p orbital, so this is px orbital, this is py orbital, this is pz orbital. Okay, like d orbitals, you have dxy, dyz, dzx, dx square and y square and gz square. Just let me talk about that. So this is x y का बीच में d orbital डबल डम्बल आ रहे हैं, dxy orbital. So Uday, hope you are understanding. So dyz, zx, and on the axis, that is dx square and y square, and you can say it is dz square on z axis. Oh yes, very good. So these orbital जो है ना, इलेक्ट्रॉन क्लाउड का जो शेप होता है, that is called orbital. जो शेप का नाम है स्पेरिकल, डम्बल, डबल डम्बल, f ऑर्बिटल है तो क्वाड्री डम्बल भी आएगा, है ना. Let's talk about this overlapping. This overlapping, sigma overlapping in the sigma, s orbital, s orbital, s overlapping, and s orbital, p orbital, sp overlapping, example HCl, है ना, and you can say pp overlapping, and it is about fluorine, you can take a chlorine, you can take a bromine, you can take iodine, है ना. This is about, yes, thank you very much. So among all overlapping, so the strength of the orbitals, so p overlapping is stronger than sp overlapping is stronger than ss overlapping strength, and this is the criteria where strength is about the lowest shell forms the strongest bond. Yeah, orbital means the shape of the electron cloud. Exactly, Uday. Exactly. Okay. So let's talk about pi bond. If the orbital and orbital overlap like this, that is called sigma bond. If the orbital and orbital overlap like this is what you call it as a pi orbital and pi bond. So the lateral overlapping of the atomic orbital, you can say it is what you call it as a pi bond. Of course sigma bond is stronger है, pi bond weak है. Sigma bond can be independently formed and pi bond is formed only after sigma bond, है ना. So many kinds of differences you can say. So and this is very important, this is the nucleus beta, this is the nucleus. When these two are joined, na pi bond is formed, and pi bond is subdivided into above and below the internuclear axis. It has no symmetry and hybridization. Now the main course for the hybridization, you have many types of hybridizations. Of course, hybridizations you just study as fundamental and apply as advanced. Mind it, that kind of interpretation you need to give. So spontaneous intermixing of atomic orbital, so before bond formation, is called hybridization, my dear students. In this hybridization, atom जो है ना, इसका अंदर ऑर्बिटल्स होता है. एटम जो है ना, इसका अंदर ऑर्बिटल्स होता है. ये एटम मुलाकात करके एक मॉलिक्यूल बनेगा. ये केमिकल बॉन्डिंग प्रोसेस का है. ये प्रोसेस में पहले जो बॉन्ड बनाने का पहले वक्त में ये जो एटम का अंदर जो ऑर्बिटल है ना, ये ऑर्बिटल मेक्स मोर एफिशिएंट and they modify themselves and makes more efficient orbitals. This is also make more efficient orbitals. जो modified orbitals है ना, hybrid orbitals बोलते. So hybrid orbitals और ए ऑर्बिटल मुलाकात करके अच्छा तरफ बॉन्ड बनाने के कोशिश करता है ना बेटा. दैट इज व्हाट यू कॉल इट एज हाइब्रिडाइजेशन. हाइब्रिडाइजेशन कंपलसरी पैटर्न नहीं है. सो अगर चांस मिलेगा तो हाइब्रिडाइजेशन कर सकते हैं. इफ नॉट प्योर ऑर्बिटल भी इस्तेमाल कर सकते हैं. जो ये प्योर ऑर्बिटल क्या है? प्योर ऑर्बिटल है असली ऑर्बिटल. आपको जो एसपीडीएफ पता है ना, ये एसपीडीएफ ऑर्बिटल्स आर द प्योर ऑर्बिटल्स. ये एस ऑर्बिटल पी ऑर्बिटल जो फिर मिक्स करके और नया ऑर्बिटल्स बना रहे हैं ना, दैट इज व्हाट यू कॉल इट एज हाइब्रिड ऑर्बिटल्स. सो दीज हाइब्रिड ऑर्बिटल्स विल टॉक अबाउट लाइक दिस हाइब्रिड ऑर्बिटल्स ऐसे दिखते हैं आपका. हर हाइब्रिड ऑर्बिटल का शेप ऐसा होता है. ये स्ट्रक्चर का न्यूक्लियस है, ये एटम का न्यूक्लियस है. राइट बेटा? यस. So Uday, you kept quiet. What happened? You involved deeply into the class. Right. Now let's talk about rules for hybridization. If you know these rules, na, you can attempt the hybridization like a pro. Otherwise, kahi tak jayega. So only orbitals of nearly same energy belonging to the same atom or ion can take part in hybridization. Yes, I know that you are listening me. Number of hybrid orbitals formed. आपका जितना प्योर ऑर्बिटल्स मुलाकात कर रहे हैं ये उतना ही और हाइब्रिड ऑर्बिटल्स दे सकते हैं. ओके, and most of the hybrid orbitals are similar. Okay, the shape and size and the energy of the hybrid orbitals that are formed should be nearly same. And actually the orbitals which undergo hybridization are not the electrons. Okay, that's a controversial statement. Okay, actually hybrid orbitals and electrons, electron and orbital is same. Okay, that's why. So anyways, sp types of hybridization, one is sp hybridization. sp hybridization means yes, s orbital and p orbital बीच में hybridization कर रहे हैं, that is called sp hybridization. एक minute. yes, s orbital p orbital बीच में hybridization हो रहे हैं, that is called sp hybridization, and it has two lobes at the end. So you can see this is one hybrid orbital and this is one hybrid orbital. So two lobes looks like that, that is what you call it as sp hybrid orbital. yes, you can see like this है ना. एंड उसमें एक 50% कैरेक्टर एस कैरेक्टर है, 50% पी कैरेक्टर आना है. ओके, नाउ वन मोर ट्राइगोनल और sp2 हाइब्रिडाइज ऑर्बिटल्स. सो उसमें एक s ऑर्बिटल है, एक p ऑर्बिटल है और एक p ऑर्बिटल है. सो दैट you said it is s and p two orbitals. That is the meaning of that, right? When these three are combined, you got one sp2 और एक sp2 and और एक sp2. There are three orbitals that are seen. You understand? The way you have to understand like this only. So it has trigonal planar shape and it has 1/3 of s character and 2/3 of the p character you have. है ना उदय? And tetrahedral hybridization, sp3 hybridization, in that one s orbital and you can see one s orbital and एक px and एक py and एक pz, and you are going to get sp3 hybrid orbitals like one lobe और दूसरा एक and third one and the fourth one, like that. 4. It is tetrahedral hybridization, Uday, and you have sp3 dehybridization. In that one s orbital and 3 p orbitals and one d orbital, usually dz square. So that is what you call it as sp3d hybridization. In that you can take PCl5 is an example. Phosphorus has 1s2, 2s2, 2p3 and थोड़ा एक्साइट करके ये इलेक्ट्रॉन यहाँ से यहाँ जंप करने के बाद, उदय होप यू अंडरस्टैंड, यहाँ इलेक्ट्रॉन यहाँ घुस गया. सो उसमें एक s ऑर्बिटल है, 3 p ऑर्बिटल है एंड एक d ऑर्बिटल है. सो पूरा मिलके sp3d बन गया. So this is what, and PCl5 is formed. Yes, very good. And there are two sets of equivalent orbitals like phosphorus equatorial bond, equatorial bond and axial bond. And equatorial bonds are short and strong, and axial bonds are long and weak. Now in this way I would like to say proton neutron, Anushka, proton or neutron are subatomic particles है ना, we'll discuss. Yes, equatorial bonds and axial bonds. That's the reason why when you heat PCl5 है ना, it is going to give you PCl3 and Cl2. That is the example we can say this equatorial bonds and axial bond ऐसा लगता है. Yes, very good. That's good. Now sp3d2 फिर भी SF6 is an example beta. We already discussed the shape of SF6. So उसमें S, Px, Py, Pz and dx square and y square plus dz square and पूरा मिलके आपका sp3d2 होना है. उसमें सल्फर ग्राउंड स्टेट and excited state of sulfur atom, ये electron यहाँ आना, ये electron यहाँ आना, so that you are going to get sp3d2. That sp3d2 क्या क्या d ऑर्बिटल इस्तेमाल किया जाएगा? That's very important question, very important question, mind it. ठीक है, very important. Next, how to find hybridization? This is very important, है ना? Yes. इसका स्ट्रक्चर भी याद करना है. ऑक्टाहेड्रल है ना बेटा उदय, you can memorize it, you can do it, है ना? Right. So this is the simplest trick I have. I am going to give it to you. Take it, Uday. H is equal to half V plus M plus or minus C. This is the best formula that I can give you. So what is that? So H है ऊपर number of hybrid orbitals का है, V है number of valence electron है, M is the number of monovalent electrons attached to the central atom, and C is the charge. You have to reverse the sign. है ना बेटा? अभी बोलो. So अगर आपका H AR is equal to 2, H R is equal to 3, H4, H5, H6 like that. अगर H वैल्यू आपका निकलेगा तो SP2, SP3, SP3D, sp3d2. I say, can we go with a couple of questions based on this? Uday, can you tell me? Let us talk about use this formula only for simple inorganic compounds. Simple inorganic compounds. Okay? So let's talk about a simple molecule SiCl4. Okay, इसका hybridization है. So H is equal to half V plus M plus or minus C, है ना? So H, V, silicon का valency, how much? Carbon, silicon, germanium, tin, lead. So 4. सिलिकॉन का 4 मोनोवैलेंट एटम, उसमें चार्ज कुछ नहीं है. ओके, 4 + 4 8/2 इज इक्वल टू 4. सो 4 है ना तो sp3, दैट इज गोइंग टू बी sp3. सिंपल है कि ना? अंडरस्टैंड है कि ना? वेरी गुड. नाउ लेट अस टॉक about this one. SO2 H is equal to half V plus M plus or minus C. So of 6 plus oxygen is a divalent, is not a monovalent, make it 0 plus or minus 0. So 6 by 2 is equal to 3. अगर 3 होगा तो sp2 बोलो, sp2. Understand? Very good, nice. Now let us talk about CO3 2 minus, कार्बन का हाइब्रिडाइजेशन. वेरी गुड, एक थम्स अप दे उदय. Very good content I am giving na. So that, so H is equal to half V plus M plus or minus C. So half valency of carbon is 4 plus monovalent atoms कुछ नहीं है. So here minus 2 ना, make it plus 2, reverse the sign. अगर आपका इलेक्ट्रॉनिक कॉन्फ़िगरेशन पता होता है तो वैलेंस निकाल सकते हैं. उदय सिंपल ट्रिक है ना. Yes, that's fine. So 4 plus 2 is equal to 6 by 2 is equal to 3. sp2 hybridization. Anything you can do it. Any molecule hybridization you can do it. है ना? है ना? उसमें कुछ खास बात नहीं है. You can really enjoy it. You can really enjoy it. है ना? You just want to talk about any molecule other than this. Okay? Any molecule you can say ClF3. So V is equal to half V plus or minus C. So chlorine is a halogen, 7 electrons है, and 3 fluorines है ना, 3 fluorines है ना. So each fluorine atom is a monovalent atom, plus or minus उसमें कुछ charge नहीं है, 0. 7 plus 3 by 2 is equal to 5. sp3 hybridization. Very good. You are teaching like a Pepsi. दिल मांगे मोर, चाहिए तो ले लो, है ना बेटा. And very good to see that you all in the class, very good number of students are there in today. We had Fajan rule recapture, and we had valence shell electron pair repulsion theory, ionic bond properties. After that, formal charge, covalent bond, dative bond, VSEPR theory, VBT, hybridization. ये hybridization हमारा क्लास में we broke the entire rules and we got a simple trick to calculate the hybridization. है ना उदय? एक बार thumbs up emoji देना 2 बार. And we are going to discuss more tomorrow about alcohols, phenols and ethers. Till then, and please like the session and share it and subscribe it. And thank you, bless you all my dear students. Okay, thank you, God bless you. Signing off, Suresh, Faculty of Chemistry. Okay, okay, from Infinity Land. Take care, God bless you, bye.